Okay, so equivalent expressions are just basically equations, aren't they? It's two expressions that you can put an equal sign in between, okay? So if you have equivalent expressions, you have an equation. And if things are equal in mathematics, you can use one to substitute in and replace another one, okay? Let's look at exercise 1 here. They have these three expressions here. 5 times the quantity x minus 3 in parentheses, 5x minus 3 and 5x minus 15, okay? So they want us to substitute in these values of x for each of those, right? And then determine which of these expressions are equivalent. Now maybe you can look at it and tell, right? Right? Like, short of having to plug these in, could you guys just see if you distribute this 5 through here, you'll get one of those two? Okay, so let's do it the way they said. So let's plug in this x of 7, right? So you'll have 5 times 7 minus 3, right? Which is 5 times 4, 20. Right? Any idea? And again, this is, your work should look like this up here too, okay? And let's do this one here. So 5 times 7 minus 3 is 35, right? Minus 3, which is 32. Are these equivalent equations? Right? And if you were to distribute that 5 through here, would the result be a 3 here? 5 times 3 is what? 15. Wait. Okay, let's plug in the last one here. 5 times 7 minus 15 is 35 minus 15, which gives you what? 20. So it looks like these two match up so far. Okay? Now, just because two expressions are equal for a particular value you plugged in doesn't mean they're always equal, right? So if you can do it this way, you got to check a few values of x. So let's try x equals 0. Right? That equals 5 times what? Not 3. Negative 3, right? And 5 times negative 3 is? Negative 15. Let's check this one. So 5 times 0 minus 3. That would be 0 minus 3, right? And what's 0 minus 3? Okay? They're not equivalent. Let's try the other one. 5 times 0 minus 15 equals, 0. So that's negative 15. So again, these guys look to be equivalent. Okay? And we could check the other one here. But let's not take any more time up, okay? So it appears that this expression here is equivalent to this one. Right? So I would write down here this 5 times x minus 3 equals that one. Okay? But then without plugging in, we kind of talked about, you know, why they would be equivalent even before you know anything about plugging in for an x, right? So what property would you say we would use to show that these two expressions are equivalent? Monday. What property? Go ahead. Still couldn't hear you. It's one of these three. Speak up, man. Confident. Which of those three properties will we apply here? Associative? Well, you see in parentheses, right? And I know associative property, you usually see parentheses, but not in this case. You're going to distribute, right? It's a distributive property. Because we distribute that 5 through. So which property is the distributive property? Okay? So let's just do that then. So that was 5 times x minus 3, right? And if you distribute that 5 through, what do you get? 5x minus 15, right? Exactly that other expression. Let's take a look at exercise 3. Exercise 3. Which of the following expressions is equivalent to 5 times 2x plus 1 minus 4? Show your work. Guys, it's multiple choice, but I don't care. They're invalid, so we're going to do it just like it's not a multiple choice, okay? So what are we going to do to this expression to determine which one of these four it's equal to? Huh? Distribute, right? And maybe combine some like terms, right? So we do 5, 2x plus 1 minus 4. Okay, so distribute that 5 through. What do we get? Speak up. 10x plus 5, and then minus 4 is still there, right? And now we can combine like terms, the 5 and 4, right? So 10x plus 1. Okay, simple enough. Again, guys, this is what your work should look like when you turn your homework in and on tests, okay? So it's choice 3. Any questions on that? They're equivalent. They're equivalent because we use one of the properties, right? Whenever we apply any of those properties that we learned Monday, you end up with equivalent expressions. Right? Let's go to exercise 4. Okay, so it's a little like the one we just did. Which one is equivalent to those four choices? We have this 4 times 3x plus 1 minus 2. Minus 2 on the outside, the whole thing over 2, then minus 5 tacked on there. So I'm going to give you guys a minute to work through this. What is the first thing you're going to do to start simplifying this? Distribute through the 4, right? Now this horizontal fraction line, remember, is also a what? Yeah, grouping symbol, right? Okay? So for your PEMDAS, you're going to think of it that way. And this minus 5 will probably just go along for the ride all the way down to the end probably, okay? So I want to take a minute and work through this, kind of know what it's supposed to look like. I'm going to actually I want to take it over here so I have a little more work because there's something else I want to show you. So we have our 4 times 3x plus 1 minus 2 all over 2 minus 5, right? Let's distribute through the 4. What do you got? Minus 2 all over 2, right? Minus 5. Okay. Well, let's still, right, because this is like parentheses up here, right? You don't need to put them in, but, so we need to maybe combine like terms up in there, and what do you get? 12x plus 2, right, over 2, minus 5, right? So, like I said, minus 5, so you can go along to the right. Now, there's a couple ways you can handle this part, right? Remember we talked about distributing through a fraction? Right? So one way we could do it is just divide this term and this term, the 12x and 2, by 2, right? We could do 12x over 2 plus 2 over 2, right? Or we could do it like we did in the notes on Monday. I'll just say or over here. What's the matter? It sounded like you were in pain. Or I could do this. Remember, dividing by 2 is the same as multiplying by 1/2. Right? Either way. Either one of those steps, I don't care, right? So let's simplify this one. What's 12x divided by 2? 6x plus what? 1 minus 5. So that's 6x what? Minus 4. Okay? Choice 4. You guys get a little better idea what your work should look like, right? Okay? Now, as we go along, get a little more sophistication, like, you won't necessarily have to show every tiny little baby step, right? Because soon we'll all be smarter, right? And if we don't show every step, at some point, everyone will know what you did, right? But for now, you got to be a little detailed about it. All right, let's go on to this last one here. Not quite the last one. Exercise 5. which is equivalent to 10x plus 15. What is, yes, ma'am? Huh? Why don't you tell me what you think the answer is? Let's start with that. Choice 2? What makes you think that?
Because 10 divided by 2 is 5, and that's what's on the outside. And 3 divided by 3. 15 divided by 3 is 5.
Oh,
And that's what you're distributing.
okay, so it looks like they took these two terms and divided it by 5. So what you guys are doing, isn't that the actual opposite of distributing or multiplying? What's the opposite of multiplying? You just did that, right? And when you do that type of thing with this type of expression, that's what's called factoring. So these are the factors of that expression, right? So really what you could do is kind of check each one of these, right? That would be 16x plus 26, nope, right? There's my 10x plus 15, right? Okay? So what you did when you start with this and go backwards to one of these, it's called factoring. Have you heard the term factoring before? I knew you had.
No.
Probably just did it with numbers, like factors of 10, 2 and 5, right? 2 times 5, right? It's basically what we did here, but with an expression. The factors of 10x plus 15 are 5, and this quantity 2x plus 3, okay? So that's what we're on to now. So when you do the opposite of multiplying or distributing, you're doing what's called factoring, okay? So this is actually the inverse, whoops, we call this the inverse of distributing. Ah, okay, a little sloppy. So when you're looking through, like in that last example, like what does it look like they factored out? You always want to find a common factor, right, between the two of them. In that case, before it was a 5, right? And you want to make sure it's the greatest common factor. You've heard of that term, right? Okay, you want the greatest common factor. Greatest common factor. Or GCF. Okay? Because some terms in the expression will have more than one common factor. So maybe they're both divisible by 2 and they're both divisible by 3, right? So you want to pick the 3. Yeah, good. All right, so let's see if we can find a common factor for both of these. So let's take this over to the opposite of distributing. What do you think is the greatest term we could factor out of each of those? Not 3x? No, because there's no x term in the 21, right? So just a 3. So if we factor out a 3, what gets left inside the parentheses if we divide each one of these by 3?
2x.
Yep.
Plus.
There you go. Right? Just look at that. If I distribute that 3, don't I end up with the 6x plus 21? Okay? All right, let's try this one here. What could I factor out of here? A 2? Yep. Not a 2x? Could I factor out also a negative 2? Yeah, I could do that too, couldn't I? I think I want to factor out a negative 2.
What negatives do you have?
If you multiply, yes.
A
Or
negative
divide.
5.
Well, let's do it. Let's factor out a negative 2 and see what happens. Okay, what gets left in the parentheses? Negative 2 divided by negative 2 is what?
X.
Right, yeah, it's 1. We don't have to write a 1, right? Remember, you always assume there's a 1 in front. You don't have to write 1x. What you want to?
X minus 5.
X minus 5. There you go. Right? Okay, you guys try part C there. Let's see if you get this one. I think you're getting the hang of it. 7, right? And they're both factors, they're both common factors. But let's use the 7. And what's that leave inside? Or 2x, yep. So we factor out a 7 and we're left with 2x plus 2. So you added 2, which means you had probably what, 7x plus 7, right? And then you probably should look at it and go, ooh, 7. Factor that out too, right?
So like the largest number that is the factor.
Of both of them, yes. It's the greatest common, one that's the largest one they have in common, greatest common factor. Okay? All right. Well, we have some Regents questions we need to take a look at here, okay? So these are important because you're going to have this exam in January. So what I want everyone to do right now is take a look at this first one. Now again, some of these are multiple choice. Do I care? What do you need to show? Just like it wasn't a multiple choice, okay? You know what I mean? On the actual exam itself, if you want to treat like, she'll work on these, but now you're here to learn it, and the only way to learn it is to not guess. Yes?
What do you mean, like, they're invalid?
Because you can circle the right answer without knowing what you're doing by chance. Or like do little multiple choice tricks and things to figure out, like reverse engineer, which is not using the technique I taught you, right? So it was a good question, by the way. So presumably you were here to learn what I teach you, right? And if you're guessing on multiple choices, that means you didn't learn. I didn't teach you to guess, did I? I'm teaching you to be little mathematicians out there, right? Okay, got choice. How many got choice 4? Okay, so the rest of you need to be confused? Okay, so let's write this down. So 2 times x squared minus 1 plus 3x times x minus 4 equals. Let's start by distributing. Maybe I'll just go down. I'll go vertically. Let's distribute the 2. It is, yep, 2x squared minus 2, right? And now let's distribute this 3x through here. 3x times x is 3x squared, right, everybody? Okay? Minus 12x. Now what do I want to do? Combine like terms, right? So I got some x squared terms here and here. I can combine those, yeah? So that's 5x squareds. And then I have just this x term here, so what? Minus 12x and then minus 2. So you guys that were struggling, do you understand this now?
I was gonna say, I got 4.
5x squared minus 12x. Yeah, it is 4. Is it?
Yeah.
Then I guess I missed what you didn't understand.
No, I understood it, but I thought she said she got 1.
No, you said 4, right?
Yeah.
You said 4.
Oh.
You guys got to speak up and avoid all this confusion. Okay. Let's move on to part 2. Read that over. Set this up, do the proper work. Okay? Remember, if things are equal in math, you can replace them with one another, can't you? Substitute them, yes? Okay. So c equals 2a squared minus 5, and d is 3 minus a. They want c minus 2d. C minus 2d. Well, this here doesn't look like any of these answers, right? So what should we do with this c and this d here? Yeah, you see what c is equal to? Replace it. And the d? Well, you better replace it with parentheses, right? So c is 2a squared minus 5 minus 2. Now don't do this. Is that right or wrong? It's 2 times d. This is not 2 times d, right? What do I need to put here? Yeah, 2 times that whole quantity d. Get the idea? Okay? Now you guys distribute through and simplify it. Let's see how we do. And by the way, your tests are going to be made up predominantly of these Regents questions. Okay? Not exactly like you see them here. They'll be changed, right? So you definitely want to focus on these. Everybody got it? Yeah? What you get? 4, he said? She says 4. What do you guys think? We get something different, or they get 4? Well, it's not 4. I won't leave you in suspense anymore. Are you just like working down the list, or? Okay, so you saw something about your answer that gave you 4, and you thought, oh, maybe my answer should be 3 based on something, right? Well, let's go through and see. So this would be 2a squared minus 5. Then what, guys? What gets distributed here, by the way? A negative 2, not a 2. Right? A negative 2 gets distributed. Catch that? Not just a 2. So what does that give us? Negative 6 plus what now? Plus 2a. Negative times negative is positive 2a, right? And now we can start with a 2a squared plus 2a. And negative 5 minus 6 is what, everybody? Negative 11. So it's choice 3. Okay? Any questions on this one? Listen, it's really important that if you're not understanding how to do one of these, that you raise your hand now, okay? Ask, let's get it figured out, because these will be on your chapter test. Okay? Anybody have an issue they want to talk about with number 2? Okay, let's move on to number 3. It's a lot like number 2, isn't it? Kinda. Ooh, yeah, it's tweaked a little bit, but yeah. A weird. Oh, trinomial. Is that the weird word? All right, real quick. So, oh, I don't know. Maybe I'll. Oh, wait a minute. Maybe I'll put that on the notes page. Polynomial. That's just a general term for like a multi-termed expression, right? Poly is not any number, right? Multi-term. Right? And then you have a type of polynomial as a monomial. What's that? Wouldn't that just be one term expression? What would a binomial be? Huh? One more time. What? No term? 2. Yeah, 2 terms. What about trinomial?
3.
There we go. Yeah. Right? So polynomial is not any particular number. That's just like the general term for any equation or any expression. And then these are specific ones. Okay? I thought I kind of talked about that the other day. I don't remember though. Are you sure? Maybe it was the other class. I don't know. All right, let's go back here. Trinomial. Hey, by the way, this here is a trinomial, isn't it? Because it's got 3 terms. And what's this other one? Binomial, 2 terms. Yeah, okay. So C equals G minus 3F. Right? What do I do with this G? Replace it with what it's equal to, right? 3x squared plus 4 minus 3. What do I put in place of the f?
3 plus 2x.
Not plus. It's not 3 plus f, it's 3 times f, right? So what do I need here? Because this is going in for f, isn't it? So what do I have to put here? There we go. 2x squared plus 6x minus 5. Okay? So nothing's really going to happen here. So 3x squared plus 4. Now what are you going to do? Distribute that negative 3 through the negative 3, not just a 3, negative 3. What do we get when we do that? Minus 6x squared. Minus 18x.
Positive.
Plus, right? Negative 15, right? Now what do we need to do?
Add like terms.
Yeah, got these here. So 3x squared minus 6x squared is what?
Negative 3x.
Negative 3x squared. Keep going. Let's go with the x terms. Let's take care of this guy. Minus 18x, right? I want them in standard polynomial form, right? And now we have the 4 and the 15, right? Both positive. There we go. Okay? How your work's supposed to look here, right? Okay. Any of you if anybody is lost about in this problem, ask now. Okay? Remember, do not answer questions on test day. You either know it then or you don't, and now is when you find out if you don't know. Okay? Lost, you say something. Okay. Let's move on to number 4.
What is the test?
What is it?
When is the test?
It's going to be maybe like Tuesday, Monday, Tuesday, something like that.
Next month, out on a day. I don't know which day. So.
Okay, well, that's part of it, right? So if you know you're going to be out on test day, let me know and we'll arrange something, okay? But I got to figure out what day, because I was out yesterday and I'm skipping a minute, so I got to kind of recalculate where it's going to fall. I'll let you, and by the way, when I give you a test, guys, I give you a review that looks almost exactly like it. It's almost like the test itself, right? So if you can do that, you're fine on the test, okay? All right, on to number 4. Starting to look a little familiar, isn't it? Here's something that y is equal to. There's something that z is equal to. And they want to know what 2y plus z is. You're just going to do what? Replace y with what? Yeah. And then replace that z with what? Yeah. When you do that, I wouldn't distribute right away. I might combine like terms and simplify a little, right? You could, but get a little messy. Okay, so that y here becomes this, because it's equal to it, plus the z, right? So I can distribute here the way it is. But again, you might want to simplify it first and then distribute because it's less likely to make an error, I think, right? So they give us 2. Let's start with the highest exponent, 3x cubed, right, to the 3rd. Right? Then what? Yep. So what? Plus what? 2x squareds there, right? Are there any just x terms? Nope. Negative 5 minus 12 is what? Okay? Now we can do what? Now distribute through the 2, right? So that'll equal what? 6x cubed.
Plus 4x squared.
Yep. Minus what? 34, right? There you go. What choice is that? Choice 1. Okay? Anybody have an issue with that? But you know, like, so I see some kids, like, they'll do that substitution, then they'll distribute here. Like, yeah, it could still work, right? But you're doing more distributing And like the more steps you take, the higher your chances for a mistake would be, right? Okay. Let's do the last one. I think you guys should be able to do this one okay, right? Distribute the 3, and then tell me if I'm correct. Distribute the 4.
Yeah.
Huh?
4.
Yeah, the -4. Yes. When she gets back here. Does she usually take that long?
She did yesterday. She was like sick or something.
Oh.
That girl took like 2 hours in the bathroom.
Well, why don't you go, and if you see her in there, tell her to wrap it up.
Oh, we gotta keep trying.
Okay. You guys go ahead and do this. I'm just gonna jot it down. Well, yeah, just write it down here. 3x squared, careful, get it right. Plus what?
6x.
Yep.
Minus 16x squared.
Now we're doing it minus 16x squared
Plus 28.
plus, right, 28x
Minus 20.
minus 20. Okay? We combine it like terms, we find the stuff with the highest exponent first. Here and here. So it's 3x squared minus 16 of them gives you what? Negative 13x squared. Is she in there?
Yeah.
Okay.
Why are you so intelligent?
Me? Oh. All right, 6x and 28x is what?
34x.
Negative 9 minus 20, that's just negative 29, right? Okay? And that's choice 2.